Okay, question 3. Complete this table of values for y is 2x plus 2 from x equals minus 2 to x equals 3. So here, each time we're given a number, we need to substitute that number in place of x here and then work out what the y value will be. Okay, so we start off, let's do the two test values that they've given us. So when x is 0, 0 times 2 will still be 0, plus 2, 0 plus 2 gives us 2, so that's how that's working. And this negative number here, if we put minus 1 into that, 2 times minus 1, 2 lots of minus 1 will be minus 2, minus 2 plus 2 takes us to 0, so that's how these two are working. Okay, so now we'll put minus 2 into the equation, and we get minus 2 times 2, 2 times minus 2, that gives us minus 4, but minus 4 plus 2 will give us minus 2. Okay, so we can put minus 2 in that box there. Then 1, 2 times 1 equals 2. And then add the 2 on, gives us 4. Okay, so we can put 2, 4 in there. 2, double it gives you 4, plus 2 gives us 6, 3 doubled gives us 6, plus 2 gives us 8. Okay, then it asks us to draw the graph of y equals 2x plus 2. So for each of these pairings, we're just going to plot that point. So for this pair here, we're going to plot the point negative 2 by negative 2. Okay, and that point will be negative 2 on the x, negative 2 on the y, takes us to here. Okay, here it's negative 1 on the x by 0 on the y, so that's just there. Then 0 by 2 is there, 1 across and 4 up is there, 2 across and 6 up is there, 3 across and 8 up is there. Okay, and then you join them all with a line to see what this is the equation of all the possible values of x that there can be, not just the values of x that we happen to have plotted. So really we could have put any numbers into these x values and it would have given us a point somewhere on this line. So if you think about it, this line is made up of millions and millions of tiny dots or points. Okay, and then we can use that graph to find a value of y for an x that we haven't tried out so far. So we find x equals minus 1.5, which is there. So then we'll draw down till we hit the line and then draw across from there and we hit negative 1. So that's our matching y value. And then here, when y is 7, this is the other way around now, when y is 7, so that's there, stretch across to the line, drop that down, and we get an x value halfway between 2 and 3, so that's 2.5. Okay, and let's have a look on the mark scheme. Those are the points that we had to plot. You get 2 blind marks if you've done all 4 values correctly. If you've only done 2 or 3 of them correctly, you drop 1 mark there. You get 2 marks for a correct straight line through all of the points, or B1 for a line which is passing through one of the points that was given to begin with and has approximately the right gradient. Okay, and then we have to have -1 and 2.5. They're just B1 marks for both of those. Okay.